Take a look at this. This levitation experiment is caused by ultrasonic vibrations that you cannot see or hear, creating an awe-inspiring effect known as acoustic levitation. This is so profound to say. Sound is all around you every day. For centuries, levitation has been a recurring theme in myth, legend, and lore, making it seem impossible for humans to achieve. However, recent technological advancements have proved this wrong, because scientists have found that they can use acoustics to bring levitation outside the realm of Yoga Sutras and into the real world. How was this discovery made, and how is it going to transform the world we live in today? Scientists and scholars have discovered that vibrations possess greater potential than the known creation of sound. In fact, with the right technology and techniques, vibrations can enable us to defy gravity. This discovery sheds light on how ancient Egyptians moved and cut large stones to construct pyramids. Here's proof that sound-based levitation works. In 2015, a group of Spanish scientists successfully built a device that used sound to keep small objects suspended mid-air.
We call these transducers, which is just a fancy word for speakers. These speakers, they only work at one frequency, and this frequency is 40 kilohertz, which we shouldn't be able to hear, but they are very, very powerful. They only work at one frequency, but they are very powerful. So if we switch on the device, now all the transducers should be emitting, and luckily we shouldn't be able to hear anything. Only bats, dogs, and other animals should be able to hear 40 kilohertz. But because the ultrasound is so powerful, if we put some particles, they should be kept in midair with the power of sound. And all these things that they are just being like kept there with air, actually it's not air, it's the ultrasound pushing them from all directions.
Now let's examine how scientists began exploring and developing this groundbreaking technology. Humans' fascination with levitation dates back many centuries. Ancient myths and stories from various cultures depict floating objects and people with these supernatural phenomena, frequently attributed to divine or mystic powers. Fast forward to the late 19th and early 20th centuries, the advent of modern science began transforming these myths into reality, although in small and controlled ways. During this period, pioneers of science like Nikola Tesla began experimenting with high-frequency sound waves. Tesla's work laid a solid foundation for our current understanding of acoustics and its potential applications. Acoustic levitation is the suspension of matter in the air against gravity using acoustic radiation pressure from ultrasound waves. Ultrasonic sound waves have frequencies exceeding the upper audible limit of human hearing, around 20 kilohertz. Ultrasonic waves can penetrate different materials and reflect off surfaces, making them extremely useful for imaging. They do, however, have enormous potential beyond their application in imagery. These high-frequency sound waves can also exert radiation pressure on objects, resulting in the fascinating concept of acoustic levitation. The possibility of acoustic levitation was first demonstrated by chance in August Kundt's tube experiments in 1866. Kundt, a German physicist, conducted this series of experiments in a resonant chamber to determine the wavelengths, and thus, the speed of sound within a gas. However, due to these experiments, a new field emerged: acoustic levitation. These nodes and antinodes then trap and hold small particles in place. Firestone's experiments were revolutionary, showing that sound waves could counteract gravity. The latter half of the 20th century saw significant advancements in acoustic levitation. Scientists and engineers continuously refined the technology, improving its precision and expanding its applications. In the early 1980s, Japanese researcher Sho Asano made more notable contributions to the field by developing more sophisticated levitation devices capable of handling larger objects with greater stability. Asano's work helped push acoustic levitation from a mere scientific curiosity to a practical tool applicable to various fields. However, the most significant advancement in acoustic levitation was in 1987, when Dr. David Deek collaborated with NASA on a microgravity experiment, developing an acoustic levitation device that only required one pair of transducers. He designed and built a 12-inch cubed plexiglass Helmholtz resonant acoustic levitation chamber. The resonant cavity had 3 speakers attached to the cube by aluminum acoustic waveguides. With his invention, Dr. David Deek was able to control levitation and movement in the 3 axes of the ambient space by using continuous resonant sound waves of up to 600 Hz, while also adjusting the amplitude and phase relationship among the speakers. Dr. Deek's research and experiments replicated on Earth the effects of microgravity conditions found in the space shuttle environment in orbit. But how exactly does ultrasonic levitation work, and what does it mean for the future of technology? Let's break down the science. The first thing to note is that its fundamental principle relies on creating standing waves using ultrasonic transducers. Ultrasonic transducers are devices that convert different types of energy into ultrasonic vibrations. They are classified according to the energy source and medium in which the waves are generated, and they come in various basic types. The piezoelectric crystal, which is the most commonly used type of ultrasonic transducer, converts oscillating electric fields applied to the crystal into mechanical vibrations. Piezoelectric transducers are widely used at all output levels and across the entire frequency spectrum. Piezoelectric crystals include quartz, Rochelle salt, and certain ceramics. Certain shapes of these materials are more commonly used in specific applications. Plain, ultrasonic waves, for example, are generated using disc-shaped piezoelectric transducers. Sound waves emitted by ultrasonic transducers reflect back and forth, creating standing waves. There is no movement at specific points along these sound waves. These points are called nodes. Due to ultrasonic radiation pressure exerted by the waves, objects positioned at these nodes remain suspended in midair. The pressure created is sufficient to counteract gravity. Scientists can then control the position and stability of the levitated objects by adjusting the precise frequency and amplitude of the sound waves produced. Following recent advancements in ultrasonic levitation, it has become a lot more versatile and reliable. To improve the levitation process, new transducer and reflector configurations are being tested. One major development is in the use of arrays. Phased arrays have been developed to speed up and simplify the process. This has made the creation of complex acoustic fields that can levitate and manipulate objects with unprecedented precision possible. This technology creates opportunities for the application of acoustic levitation in microassembly, where tiny parts of objects can be manipulated without physical contact. This technological advancement represents a game changer for manufacturing processes requiring high levels of precision. You might be thinking, what use is this technology for in real-life industries? Ultrasonic levitation holds many possibilities for already existing industries. One major application is in the study of material properties. Allowing scientists to suspend materials in midair provides a means of keeping them free from container-induced contamination. This can be of great use in high-precision experiments, often performed in chemistry and physics. The potential applications of ultrasonic levitation extend far beyond Earth and into outer space. In environments with very little gravity, such as the International Space Station, acoustic levitation can aid in studying fluid dynamics and material properties while preventing the interference of gravity. This technology is of keen interest to NASA and other space agencies, as it offers a solution for conducting experiments that are impossible to perform on Earth by providing valuable insights into fundamental questions of science. Aside from its applications in physical sciences, ultrasonic levitation is making waves in the medical and biological fields. Its potential in tissue engineering, drug delivery, and biological reprogramming is pushing the borders of science. For instance, the levitation of cells and small biological samples may provide a means for studying their behavior in a controlled environment, free from the influences of containers or substrates. This advancement could influence breakthroughs in the understanding of cell biology and the development of new medical treatments. Recent experiments by a team of scientists who mutated frog embryos into salamander embryos using specific wave frequencies have shown greater potential in gene editing. This also points to the possibility of repairing genetic damage at a faster, safer, and more precise rate. Ultrasonic levitation is of great value to the building and construction industry, as its application may lead to the production of more durable structures by enhancing curing processes. It also points to new techniques for construction, especially in hazardous environments such as underwater, in space, or in difficult terrain. Perhaps this explains the Al-Nasla rock formation of Saudi Arabia, which consists of a large rock split in two by a mysteriously straight cut and balanced on two smaller stones. Theories suggest that ancient civilizations may have used acoustic levitation for its formation. Ultrasonic levitation presents endless possibilities for revolutionizing the world as we know it. However, just like any powerful technology, there is an attendant ethical dilemma. The ability to levitate and manipulate objects with precision may lead to frequent privacy breaches and present a potential for misuse. Governments and other world powers involved in its development must ensure that it is applied ethically as it gradually becomes integrated into our daily lives. One fact remains clear: acoustic levitation will continue to push the boundaries of what is considered possible. There are various speculations on the use of acoustic levitation for human travel, but what do you think about its possibilities? If you liked this video and you want to see more amazing content, go ahead and check out the next video on our channel.